Hello, in this lecture we'll find out the radius of the circle. In the drawing we have a big semicircle. Inside this big semicircle we have two smaller semicircles and one circle. We know that this line segment equals to 140 units and this line segment equals to 70 units. Our mission is to find out the radius of this circle. So first of all, we define the relevant points with letters. This will be point, we define this point A. The center of this semicircle will be defined as point B. The touching point of the two semicircles will be defined as point C, and the center of this, the center of the biggest semicircle will be defined as O. The center of this smallest semicircle will be defined as D, and this point, that is the touching point between the biggest semicircle and the smallest semicircle, will be defined as E. The center of this circle will be defined as F. The touching point between the circle and the semicircle will be defined as G. The touching point between this circle and this semicircle will be defined as H. And finally, the touching point of the biggest semicircle with this circle will be defined as I. We will define the radius of the biggest semicircle as capital R and the radius of this circle as small r. This is the radius, small r is the radius that we are looking for. So I write it down. Capital R is the radius of the biggest semicircle. Small r is the radius of the circle that we are looking for. It is given as the question that line segment AC equals to 140 units and line segment CE equals to 70 units. And from the drawing it is very easy to see that AE equals to 140 plus 70. Okay, line segment AE equals to 140 plus 70 units. 140 plus 70 is 210 units. So AE equals to 210 units in its length. But what is actually line segment AE? From the drawing it is very easy to see that line segment AE is the diameter of the biggest semicircle. Okay, so we can write down that AE is the diameter of the biggest semicircle, and we found out that A equals to 210 units. We know that the diameter of any circle or semicircle is twice as long as the radius, and because of the fact that the radius of the biggest semicircle is defined as R. Therefore, the diameter of the biggest semicircle must be equal to 2 times capital R. So from this equation, 2R equals to the diameter equals to A equals to 210, we will derive that 2 times capital R equals to 210. Here we will divide this equation by 2 and we get that capital R equals to 210 over 2, that is 105 units. So we found out that the radius of the biggest semicircle equals to 105 units in its length. Point O is the center of the biggest semicircle. Point A is the point of the biggest semicircle itself. This is exactly the definition of a radius. That is to say, OA is the radius of the biggest semicircle, that is equal to 105 units. OA equals to 105 units. Here, point O is the center of the biggest semicircle. Point E is the point of the biggest semicircle itself. Therefore, OE is also the radius of the biggest semicircle, that is equal to 105 units. It is given as the question that AC equals to 140 units. Line segment AC equals to 140 units. But AC, what is AC? AC is the diameter of this semicircle. And because of the fact that the diameter of this semicircle equals to 140, it means that the radius must be equal to half of it. That is to say, the radius AB must be equal to 140 over 2, that is 70. And the radius BC must be also equal to 70 units in its length. Likewise, it is given as the question that this line segment CE equals to 70 units. But CE is the diameter of this smallest semicircle. And if the diameter of this semicircle is 70, then the radius must be equal to half of it. That is to say, the radius of this semicircle must be equal to 70 over 2, that is 35 units. So CD is the radius of this semicircle, that is equal to 35 units. And DE is also the radius of this semicircle, that is equal to 35 units in its length. Okay, here, what is the length of this line segment BO? From the drawing, it is very easy to see that OB, the length of OB, equals to OA minus BA. So I write it down. OB equals to OA minus BA. Okay, OB equals to OA minus BA. So OB equals to OA, the radius of the biggest semicircle, that is equal to 105 units, so we substitute OA by 105 minus BA. BA is the radius of this semicircle, that is equal to 70 units, so we substitute BA by 70. In conclusion, we found out that OB equals to 105 minus 70, that is to say, it is equal to 105 minus 70 is 35 units. So OB equals to 35 units in its length. We write down in the drawing that OB, line segment OB, equals to 35 units in its length. Likewise, we find out the length of this line segment OC. From the drawing, it is very easy to see that OC equals to OE minus CE. Again, OC equals to OE minus CE. OE equals to 105 units. This is the radius of the biggest semicircle. and CE equals to 70 units according to what is given in the question. In conclusion, we found out that OC equals to 105.70, that is 35 units. So OC is also equal to 35 units in its length. OC equals to 35 units in its length. In the next step, I will present to you two new rules, and we will implement the two new rules in our drawing. We have rule number 10. According to rule number 10, if two circles are touching each other internally, the small circle is located inside the big circle, and therefore those two circles are touching each other internally at point N. Point N is their touching point or the point of tendency. So if two circles are touching each other internally, then the straight line that connects their centers together, the center of the big circle is here at point O, the center of this small circle is here at point M. And the straight line that connects their centers together is OM. This straight line OM, according to rule number 10, must pass through their touching point, that is to say, from point N. Or OMN is one straight line. OMN is one straight line. And what is the distance between the centers of the two circles? The distance is OM. But what is the value of OM? From the drawing it is very easy to see that OM equals to ON minus MN. ON is capital R, MN is small r. Therefore, ON equals to capital R minus small r. Of course, that capital R is the radius of the big circle, and small r is the radius of the small circle. So, we found out in conclusion that whenever you have an internal notch between two circles, the straight line that connects their centers together must pass through their touching point. Here OM must pass through point N, that is to say OMN is one straight line, and the distance between the centers, that is OM, equals to the difference between their radii. That is to say, it is capital R minus small r. And then we also have rule number 11. According to rule number 11, if two circles are touching each other externally, none of those two circles are inside the other one. Therefore, in this domain, it is defined as that the two circles are touching each other externally at point N. Okay. The center of the big circle is here at point O. The center of the small circle is here at point M. And the straight line that connects their centers together is OM. The straight line OM must pass through their touching point. That is to say, from point N. Or O and M is one straight line. Again, O and M is one straight line. And what is the distance between the centers of the two circles? The distance is, of course, OM. From the drawing, it is very easy to see that the length of OM equals to ON plus NM. ON is capital R, NM is small r. Therefore, OM equals to capital R plus small r. So, repeat again that whenever we have an external notch between two circles, the straight line that connects their centers together must pass through their touching point. Here OM must pass through point N, or O and M is one straight line. And the distance between the centers of the two circles, in this case, is OM. OM equals to the addition of the two radii with each other. That is to say, it is capital R plus small r. So we actually can implement the two new rules in our drawing. this semicircle and this circle have an external knot between them at point edge. That is to say they are touching each other externally at point edge. And therefore, according to rule number 11, the center of this circle is point F, and the center of this semicircle is here at point B. So the straight line that connects their centers together is FB, and according to rule number 11, the straight line FB must pass through their touching point, that is to say for point edge, and FHB is one straight line. Okay, FHB is one straight line. And what is the distance between their centers? The distance between their centers is FB. But what is the value of FB? FB equals to the addition of the two radii with each other. The radius of this circle, according to our definition, is R, and you can see that the radius is indeed FH. But why? Because it starts from point F, that is the center of this circle, and ends at point H, that is a point on the circle itself. Therefore, FH is indeed the radius of this circle, that is equal to small r according to our definition. The radius of this circle is 70 units. And indeed, you can see that VH is 70. Why? Because line segment VH starts from the center of this semicircle and ends at point H, that is a point on the semicircle itself. Therefore, BH is 70. So, in conclusion, we found out that BF equals to BH plus HF, that is to say, BF equals to 70 plus R. So, we can write down that BF equals to 70 plus R. +R units. Likewise, this semicircle and this circle have an external knot between them at point G. That is to say, they are touching each other externally at point G. Therefore, according to rule number 11, the straight line that connects their centers together is FD, and this straight line FD must pass through point G. That is to say, FGD is one straight line. FGD is one straight line. And what is the distance between the centers of the circle and the semicircle? The distance is FD, and FD equals to the addition of the two radii with each other. The radius of this circle is R, and indeed you can see that FG equals to R, and the radius of this semicircle is 35. And indeed you can see that DG is the radius that is equal to 35 units. So in conclusion, we found out that FD equals to 35 plus R units. FD equals to 35 plus R units. So we know that FD equals to 35 plus R units. Those two semicircles have an external knot between them at this point, point C. That is to say, they are touching each other externally at point C. And therefore, the straight line that connects their centers together, that is to say BD, must pass for their touching point, that is to say for point C, that is to say BCD is one straight line. And the distance between their centers is BD. BD equals to the addition of the two radii with each other. So BD equals to the radius of this semicircle that is equal to 70 units, plus the radius of this, the smallest semicircle, that is equal to 35 units. So in conclusion, we found out that BD equals to 70 plus 35, that is 105 units. BD equals to 105 units in its length. this circle is located inside the biggest semicircle, and the biggest semicircle and this circle have an internal knot between them at point I. That is to say, they are touching each other internally at point I. And whenever you have an internal knot between two circles, then the straight line that connects their centers together must pass through their touching points. Point O is the center of the biggest semicircle. Point F is the center of this circle. So OF is the straight line that connects their centers together. And according to rule number 10, the straight line OF that connects their centers together must pass through their touching point. And their touching point here is at point I. Or OFI is one straight line. OFI is one straight line. So the distance between their centers is FO. And according to rule number 11, the distance between their centers equals to the difference between their radii. The radius of the biggest semicircle is equal to capital R. The radius of this circle is small r. So in conclusion, we found out that the distance FO between their centers equals to capital R minus small r. Capital R is 105, so it is 105 minus small r. In conclusion, we found out that the distance between the centers of this circle and the biggest semicircle of FO equals to 105 minus r units. So I write it down. FO equals to 105 minus r units. In the next step, I will present to you a new rule, and we will implement the new rule in triangle FBD, or we will implement the new rule in the green triangle, triangle FBD. The new rule is called Stewart's Theorem, and it is true in any triangle. So the triangle that I will draw could be any triangle. So this is triangle ABC, that could be any triangle. And we know that the length of side AB is equal, side AB equals to A units in its length, side AC equals to B units in its length, and side BC, this side BC, equals to C units in its length. In addition, we know that line segment AO, this line segment, it is equal to D units in its length. Line segment BO equals to M units. And finally, line segment OC equals to N units in its length. Okay. So according to Stewart's theorem, the following equation is true. A squared times N plus B squared times M equals to C. C is the length of side BC. We will open the brackets here. Inside the brackets we have D squared plus M times N. I'll repeat again. In any triangle, according to Stewart's theorem, the following equation is true: a squared times m, a squared times n plus b squared times m equals to c. Open brackets here. Inside the brackets we have d squared plus mn. Okay. We can implement Stewart's theorem in the green triangle, triangle FBD. So I will copy triangle FBD in a new page and we will implement on it Stewart's theorem. We have already found out the sides of the green triangle, and we know that line segment FO equals to 105 minus R units. Okay. Side FB equals to 70 plus R units. Side FD equals to 35 plus R units. And side VD equals to 105 units. FO equals to 105 minus R units. Line segment VO equals to 35 units. And line segment OD equals to 35 plus 35, this is 70 units. So this is triangle FBD that I copied from the original drawing. We will implement on this triangle Stewart's theorem. According to Stewart's theorem, in this triangle FBD, FB squared times OD plus FD squared times BO equals to BD. We'll open brackets here, and inside the brackets we have FO squared plus BO times OD. close the brackets. So actually, this equation is the implementation of Stewart's theorem in our triangle FBD. I'll repeat again, FB squared times OD plus FD squared times BO equals to BD. We open the brackets here. Inside the brackets we have FO squared plus BO times OD. Here we close the brackets. Okay. FO equals to 70 plus R. FB equals to 70 plus R. Therefore, FB squared equals to 70 plus R squared times OD. OD is 70, therefore we substitute OD by 70 plus FD squared. FD is 35 plus R, therefore FD squared is 35 plus R squared times BO. BO is 35, so we substitute BO by 35. Is equal to BD. BD is 105, so we substitute BD by 105. We will open the brackets here. Inside the brackets we have FO squared. FO is 105 minus R. Therefore, FO squared is 105 minus R squared plus BO is 35 times OD is 70. So BO times OD is 35 times 70. Okay. In the next step, we will define the number 35 as x, and we will substitute 35 or any multiplication of 35 by natural number. We will substitute it by x in this equation. So here we have 70 plus R squared. 70 is 2 times 35, and 35 is x. So 70 is 2x plus R squared times 70 is 2x plus 35 plus R squared is x plus R squared times 35 is x equals to 105 is 3 times 35, that is to say it is 3x. Inside the brackets we have 105, that is 3x minus R squared plus 35 is x and 70 is 2x. So in total 35 times 70 is x times 2x. Here we close the brackets. So in this equation, we will divide this equation by x. So here x will get cancelled, here also x will get cancelled, and here also x will get cancelled. So what is left from this equation after we cancelled x? We have here 2 times 2x plus R squared plus x plus R squared equals to 3. Here we'll open the brackets. Inside the brackets we have 3x minus R squared plus x times 2x is 2x squared. Here we close the brackets. So this is our equation after we divide it by x. Okay, this is our equation after we divided it by x. In the next step, we will open the brackets here. We have 2 times 2x plus r squared. 2x plus r squared is 2x squared, that is 4x squared, plus r squared, plus 2 times 2xr is 4xr, plus x plus r squared is x squared, plus r squared, plus 2xr equals to 3. Inside the brackets we have 3x minus r squared. According to the algebraic identity that a minus b squared equals to a squared plus b squared minus 2 times ab, we get that 3x minus r squared equals to 3x squared, that is 9x squared, plus r squared minus 2 times 3xr is minus 6xr, plus 2x squared. Here we'll open the brackets and we get that 2 times 4x squared is 8x squared, plus 2 times r squared is 2r squared, plus 2 times 4xr is 8xr, plus x squared plus r squared plus 2 times xr equals 2. On the other side of the equation we have 3, and inside the brackets we have 9x squared plus 2x squared is 11x squared, plus r squared minus 6xr, all under the brackets. So here in this side of the equation we have 8x squared plus x squared is 9x squared, two r squared plus r squared is 3r squared, and 8xr plus 2xr is 10xr. So in total, in this side of the equation we have 9x squared plus 3xr, 9x squared plus 3r squared plus 10xr, and it is equal to, here we'll open the brackets, we have 3 times 11x squared is 33x squared, plus 3 times r squared is 3r squared, and 3 times minus 6xr is minus 18xr. So on the other side of the equation we have in total 33x squared plus 3r squared minus 18xr. So here we have 3r squared on both sides of the equation, so 3r squared will get cancelled. What is left of the equation after we cancel 3r squared? In this side of the equation we have 9x squared plus 10xr, that is equal to 33x squared minus 18xr. In the next step, we subtract 9x squared from this equation and we'll get that 9x squared minus 9x squared is 0, so in this side of the equation we left only with 10xr, that is equal to 33x squared minus 9x squared is 24x squared minus 18xr. Here we will add to this equation 18xr, and we get that 10xr plus 18xr is 28xr equals to 24x squared and 18xr minus 18xr is 0. So in conclusion, we found out that 28xr equals to 24x squared. Here we will divide this equation by x, and we get that 28xr over x is 28r. That is equal to 24x squared over x is 24x. So here we will substitute x by 35, and we get that 28r equals to 24x, and x is 35. So in conclusion, we found out that 28r equals to 28r equals to 24 times 35. Here we will divide this equation by 7, and we will get that 28 over 7 is 4. So in total, in this of the equation, we have 4r. That is equal to 24 times 35 over 7 is 5. So in conclusion, we found out that 4r equals to 24 times 5. Here we'll divide this equation by 6, and we'll get that we'll divide this equation by 4, and we get that 4r over 4 is r. That is equal to 24 over 4 is 6. So in total, in this of the equation, we have 6 times 5. 6 times 5 is 30. So in conclusion, we found out that the radius of this circle, that is the radius that we are looking for, it is equal to 30 units in its length. In the next step, I'll summarize the lecture. In the drawing, we have a big semicircle. Inside this big semicircle, we have two smaller semicircles and one circle. It is given us the question that line segment AC equals to 140 units, line segment CE equals to 70 units, and our mission is to find out the radius of this circle. We define the relevant point with letters, and we defined the radius of the biggest semicircle as capital R, and the radius of this small circle as small r. That is the radius that we are looking for. I repeat again, capital R is the radius of the biggest semicircle, small r is the radius of the circle that we are looking for. It is given us the question that this line segment AE equals to 140 plus 70 units. So here, AE equals to 140 plus 70, that is 210 units. So line segment AE equals to 210 units in its length. Okay, but what is actually line segment AE? Line segment AE is the diameter of the biggest semicircle. Okay, and we know that the radius of the biggest semicircle equals to capital R. Therefore, the diameter must be equal to twice of the radius, and therefore the diameter AE must be equal to 2 times capital R. Okay, the diameter must be equal to 2 times capital R, and the diameter is AE, and we already found out that A equals to 210 units. So from this long equation, we will derive that 2R equals to 2 times capital R equals to 210 units. We divided this equation by 2, and we found out that capital R equals to 210 over 2, that is 105 units. So here, the radius of the biggest semicircle AO equals to 105 units, and the radius of the biggest circle OE equals to 105 units. Then it is given us the equation that AC equals to 140 units. AC is the diameter of this semicircle. So if the diameter equals to 140, the radius of this semicircle must be equal to half of it. that is to say it must be equal to 140 over 2, that is 70 units. So the radius AB equals to 70 units, and the radius BC also equals to 70 units. Likewise, in this the smallest semicircle, we have line segment CE that is equal to 70 units. But what is line segment CE? Line segment CE is the diameter of the smallest semicircle. So if the diameter is 70, then the radius must be equal to half of it. So the radius must be equal to 70 over 2, that is 35. So the radius CD must be equal to 35 units, and the radius DE must be also equal to 35 units. Then we found out the length of this line segment BO. BO equals to OA minus BA. BO equals to OA minus BA. OA is 105 units, it is the radius of the biggest semicircle. BA is 70, it is the radius of this semicircle. So in conclusion, we found out that OB equals to 105 minus 70, that is 35. So OB equals to 35 units in its length. Then we found out the length of this line segment CO. From this moment it is very easy to see that OC or CO, OC equals to OE minus CE. Repeat again, OC equals to OE minus CE. OE equals to 105 units, it is the radius of the biggest semicircle, and CE equals to 70 units. So in conclusion, we found out that OC equals to 105 minus 70, that is 35 units. So here, line segment OC equals to 35 units in its length. Okay, in the next step, I presented to you 2 new rules, and we implemented the 2 new rules in our drawing. We have rule number 10. According to rule number 10, if 2 circles are touching each other internally, here, the small circle is located inside the big circle, therefore it is defined here that those 2 circles are touching each other internally at point N. The center of the big circle is at point O. The center of the small circle is at point M. And the straight line that connects their centers together is OM. This straight line OM must pass through their touching point. That is to say, it must pass through point N, that is their touching point. OMN is one straight line, OMN is one straight line, and the distance between their centers is OM. From the drawing, it is very easy to see that OM equals to NO minus MO. Again, OMO equals to NO minus MN. NO is capital R, it is the radius of the biggest semicircle, and NM is small r, it is the radius of the small circle. In conclusion, we found out that the distance between their centers MO equals to capital R minus small r. Okay, so the distance between the centers of 2 circles that have an internal knot between them is the difference between their radii. That is to say, it is capital R minus small r. Okay, and again, the straight line that connects their centers together, OM, must pass for point N. That is to say, OMN is one straight line. And we have also rule number 11. According to rule number 11, if 2 circles are touching each other externally, here those 2 circles, none of them is inside the other one, and therefore they are touching each other externally at point N. The center of the big circle is at point O. The center of the small circle is here at point M. And the straight line that connects their centers together is OM. This straight line OM must pass through their touching point, that is to say, from point N. O and M is one straight line, and what is the distance between their centers? The distance is OM, and this distance equals to ON, that is capital R, plus NM, that is small r. So the distance between 2 centers, between the centers of two circles that have an external notch between them, like in this drawing, will be equal to the addition of the two radii with each other. In this case, it is capital R plus small r, and the straight line OM that connects their centers together must pass for point N, that is to say, O and M is one straight line. We can implement all the two new rules in our drawing. This circle and this semicircle have an external notch between them at point H. That is to say, they are touching each other externally at point H. And therefore, here the center of this circle is here at point F. The center of this semicircle is here at point B. And the straight line that connects their centers together, that is to say FB, must pass through their touching point, that is point H. That is to say FHB is one straight line. And according to rule number 11, the distance between their centers FB equals to the addition of the radii with each other. The radius of this circle is small r. The radius of this circle equals to 70 units, and the addition of the two radii with each other is 70 plus r units. So in conclusion, we found out that FB equals to 70 plus r units. FB equals to 70 plus r units. Likewise, we have the center, this circle and this, the small semicircle have an external notch between them at this point, point G. That is to say, they are touching each other externally at point G. Therefore, the straight line that connects their centers together is FD. This straight line FD must pass through point G. That is to say, FGD is one straight line, and the distance between their centers, that is FD, is the addition of the two radii with each other. The radius of this circle is r, the radius of this circle is 35, and therefore FD equals to 35 plus r. FD equals to 35 plus r, and those two semicircles have an external notch between them at this point, point C. That is to say, they are touching each other externally at point C. And therefore, the straight line that connects their centers together is VD, must pass for their touching point, that is to say, from point C. That is to say, BCD is one straight line, and the distance between their centers BD is the addition of the two radii with each other. The radius of this circle is 35 plus 35, that is 70. The radius of the smallest semicircle is 35 units. And the addition of the two radii with each other is 70 plus 35, that is 105 units. So here BD equals to 105 units. And this circle have an external notch and have an internal notch with the biggest semicircle. That is to say, they are touching each other internally at point I. And whenever you have an internal notch between two circles or semicircles, the straight line that connects their centers together is FO. Why? Because F is the center of this circle and O is the center of the biggest semicircle. So FO is the straight line that connects their centers together, must pass for their touching point. Their touching point is I. OFI is one straight line. According to rule number 10, and the distance between their centers is FO. According to rule number 10, the distance between their centers will be equal to the difference between their radii. The radius of the biggest semicircle is capital R. The radius of the small circle is small r, and the difference between the radii is capital R minus small r. FO equals to capital R minus small r, that is the distance between their centers. Capital R is 105, so we substitute capital R by 105, and in conclusion we found out that FO equals to 105 minus r units. Here, this line segment FO equals to 105 minus r units. In the next step, I presented to you a new rule, and we implemented the new rule in our drawing. The new rule is called Stewart's Theorem, and it is true in any triangle. So this triangle ABC, could be any triangle. The length of side AB is A units, side AC equals to B units in its length, and side BC equals to C units in its length. In addition, we have line segment AO that is equal to D units in its length. Line segment BO equals to M units, and line segment OC equals to N units in its length. Then, according to Stewart's theorem, the following equation is true: that A squared times N plus B squared times M equals to C, open brackets, inside the brackets we have D squared plus M times N. Okay, I'll repeat again: A squared times N plus B squared times M equals to C, we open brackets, inside the brackets we have D squared plus M times N. Here we close the brackets. So we can actually implement the Stewart's theorem in our given triangle FBD. So I copy triangle FBD in a new page and we implement it in this triangle FBD, Stewart's theorem. We already found out the size of all the sides of this triangle. We also found out that line segment F4 equals to 105 minus R units, F4 equals to 105 minus R units. OB or BO equals to 35 units in its length, and OD equals to 70 units. Okay, BO equals to 45 units, and OD equals to 70 units. We implemented here Stewart's theorem. According to Stewart's theorem, in this triangle FBD, FB squared times OD plus D squared FD squared times BO equals to BD. We open brackets, inside the brackets we have FO squared plus BO times OD. I repeat again, according to Stewart's theorem, this is the implementation. This equation is the implementation of Stewart's theorem in our triangle FBD. I repeat again: FB squared times OD plus FD squared times BO equals to BD. We open brackets, inside the brackets we have FO squared plus BO times OD. FB is 70 plus R, therefore FB squared is 70 plus R squared times OD is 70 plus FD is 35 plus FD squared. FD is 35 plus R, therefore FD squared is 35 plus R times BO. BO is 35, and it is equal to BD. BD is 105, so we substitute BD by 105. Then we open brackets, inside the brackets we have FO squared. FO is 105 minus R, therefore FO squared is 105 minus R squared, plus BO is 35 and DO is 70. Here we close the brackets. In the next step, we substitute 35 or any multiplication of 35 by a natural number by x. So 35 equals to x according to our definition. So in the equation here we have 70, that is 2 times 35, that is 2x, plus r squared times 70 is 2x, plus 35 plus r squared is x plus r squared times x times 35 is x, and it is equal to 105. 105 is 3 times 35, that is to say it is 3x. We open brackets, inside the brackets we have 105, that is 3x, minus r squared plus x is 35 is x, and 70 is 2x. So in total 35 times 70 is x times 2x. Here we divided this equation by x. So here x will get cancelled, x will get cancelled, and here also x will get cancelled. What is left from this equation after we cancelled x? This is the equation that we got after we cancelled x. Here we open the brackets. We have 2 times and 2 x plus r squared is 2x squared, that is 4x squared, plus r squared plus 2 times 2xr is 4xr, plus x plus r squared is x squared plus r squared plus 2xr, and it is equal to 3. Inside the brackets we have 3x minus r squared. According to the algebraic identity that a minus b squared equals to a squared plus b squared minus 2 times ab, we get that 3x minus r squared equals to 3x squared, that is 9x squared, plus r squared minus 2 times 3x r is minus 6xr plus 2x squared plus 2x squared. Okay, here we open the brackets and we got the 2 times 4x squared is 8x squared plus 2 times r squared is 2r squared plus 2 times 4xr is 8xr, and we copied this x squared plus r squared plus 2xr, and it is equal to, on the other side of the equation we have 9x squared plus 2x squared is 11x squared plus r squared minus 6xr. Here we have 8x squared plus x squared is 9x squared, 2r squared plus r squared is 3r squared, and 8xr plus 2xr is 10xr. And it is equal to, we open the brackets here, 3 times 11x squared is 33x squared, 3 times r squared is 3r squared, and 3 times minus 6xr is 18xr. So here we have 3r squared on both sides of the equation, so 3r squared will get cancelled. What is left from the equation after we cancel 3r squared? What is left is that in this side of the equation we left only with 9x squared plus 10xr, and in the other side of the equation we have 33x squared minus 18xr. Here we subtracted 9x squared from this equation and we found out that 9x squared minus 9x squared is 0, so in this side of the equation we left only with 10xr. And here we have 33x squared minus 9x squared is 24x squared minus 18xr. Here we added 18xr to this equation and found out that 10xr plus 18xr is 28xr, and here we have 24x squared because of the fact that 18xr minus 18xr is 0. So in this side of the equation we left only with 24x squared. So in conclusion, we found out that 28xr equals to 24x squared. Here we divided this equation by x and we found out that 28xr over x is 28r and 24x squared over x is 24x. So in conclusion, we found out that 28r equals to 24x. Here we substitute x by 35 and we found out that 28r equals to 24x, but x is 35. So in conclusion, we found out that 28r equals to 24 times 35. Here we divided this equation by 7 and found out that 28 over 7 is 4. So in total, in this side of the equation we have 4r. In the other side of the equation we have 24 times 35 over 7. 35 over 7 is 5. So in total, in this side of the equation we have 24 times 5. In conclusion, we found out that 4r equals to 24 times 5. Here we divided this equation by 4 and found out that 4r over 4 is r. And here we have 24 over 4 is 6. So in total, in this side of the equation we have 6 times 5. So in conclusion, we found out that r equals to 6 times 5. 6 times 5 is 30. So r equals to 30 units. That is the answer to our question. Repeat again, the radius of this circle, that is the radius that we are looking for, equals to r, that is equal to 30 units in its length. Okay, thank you very much.